Greetings, everyone, and welcome to the Pan Future Podcast. Today is Saturday, June 3rd, 2017. This week's show is going to be an all-news type show, but it's all news of a certain type. I've been pretty busy lately, and the deeper research projects that I get into for some of the shows just haven't had a lot of time to work through those. And let me know, drop me a line if you've got a particular topic you're interested in, you want me to dig up some more information on. There's quite a few things on my list to do down the road, and I'm always trying to schedule some interviews, and sometimes those work out and sometimes they don't, and so the news shows kind of fill in some gaps for me, and sometimes there's a lot of news and I save up a little bit of it so I can do a show like this rather than drip and drab it out and miss a bunch of stuff. And I'm probably going to miss some interesting things today, but there is one thing that all the news stories today have in common.
It came from outer space.
That's right, all the news this week comes from space. Lots of stuff has been going on, and I need to catch up. The first item this week, Tabby's star. That star that continues to confound people with its mysterious and uneven dimming as it is observed, is in the news again. Everything from transiting comets to broken up failed planets to alien megastructures has been suggested for the strange dimming of this star. However, recently, back on May 18th, a drop in brightness was detected, so a bunch of people pointed telescopes at it, and some new ideas have come around with some new suggestions as to why the star keeps dimming in ways that are outside the norm for a star that has regular planets transiting in front of it. One is Trojan asteroids following a planet around, and they could be things of various sizes, various clumps of asteroids, and could be very inconsistent in their effects on the dimming. A Trojan asteroid, if you don't know, is one that follows or leads ahead of another object in orbit. I believe Earth actually has one that was recently announced. So anyway, these groups of asteroids could be of various sizes and would cause some different results in the dimming. Another hypothesis for the dimming is a planet with a very large ring system, possibly Saturn-sized or maybe even larger, and depending on the rings and their angle, could cause some variations in the dips in brightness from the star. So Tabby's star, still a mystery, still might be aliens, probably not, but there could be, I'm guessing, multiple causes for all this stuff. There must be a lot of stuff going on in that solar system. To the moon now. In February of 2015, the National Observatory of Athens and the European Space Agency launched the Near-Earth Objects, Lunar Impacts, and Optical Transients project. Using a telescope at the Cryonary Observatory, they are watching the moon to see when impacts happen and to monitor how often they happen. On May 24th, ESA announced that the project had begun to detect impacts made possible by flashes of light being detected from the lunar surface. And this project, the NOLEOTA, is unique in that it can not only spot the flashes, but measure the temperatures that they create. And they are very interested in the types and frequencies of impacts that the moon undergoes. It could give us a better picture of how often and what kinds of things hit the moon, and possibly what kinds of things will hit the Earth. And also, this is leading some more information into what is called the European Space Agency's Space Situational Awareness Program. And in a press release, they said, these observations are very relevant for our Space Situational Awareness Program. In particular, the size range we can observe here, the number of objects is not very well known. Performing these observations over a longer period of time will help us better understand this number. So they're watching the moon, and they're seeing the stuff that hits the moon and some of the fallout results from that, and getting a better idea of how often they happen so that we can understand better how to keep astronauts safe in space and ourselves safe on the ground. Some astronomers believe that they have created the first image of dark matter. For a long time, scientists have thought that dark matter threads tie together galaxies across the universe. Theories, computer models, and indirect observations have indicated that there is a cosmic web of dark matter that connects galaxies and constitutes the large-scale structure of the cosmos. However, as the name says, they are dark and can't be observed very easily, really not much at all. However, Mike Hudson, a professor of astronomy at the University of Waterloo in Canada, along with a master's student at the time, Seth Epps, have stacked 23,000 images of galaxy pairs. And these galaxy pairs are ones that aren't just next to each other in the sky as we observe them. They are actually physically close to each other, at least close as far as galaxies go, all located about 4.5 billion light years away. So they were able to create a composite image from all these different galaxy pairs, and all that stacking revealed some images of the thread and the filament of dark matter between these galaxies. I'll link to everything, as I always do in the show notes. You can see an image of what they got out of this. Of the technique, Epps said, by using this technique, we're not only able to see that these dark matter filaments in the universe exist, we are able to see the extent to which these filaments connect galaxies together. However, as with many things in science, this is not a settled matter. One experiment, one observation, no matter how successful, still has to be replicated. Some astronomers think that either we don't understand dark matter at all or think it doesn't even exist. In 2016, physicist Eric Verlinde at the University of Amsterdam released a new theory of gravity, which he said does not need dark matter to explain the motion of stars and galaxies. Not long after, a team led by Margot Brouwer of the Leiden Observatory in the Netherlands tested his theory, examining the lensing effect of gravity around 33,000 galaxies. Her team concluded that his theory agrees well with observations. So it's still not quite a settled matter. However, and just to give you a brief history of dark matter and why this theory exists, hypothesis theory, that's a debate for another day. The Big Bang Theory predicts that variations in the density of matter in the very first moments of the universe led the bulk of the matter in the cosmos to condense into a web of tangled filaments. To explain this, astronomer Fritz Zwicky introduced the concept of dark matter in 1933 when his measurements of galaxies moving within a cluster showed that they must have 10 times more invisible matter than what is visible. This hypothesis was not taken seriously until the 1970s. Vera Rubin and Kent Ford Jr. mapped the motions of stars within galaxies close to our own, and they concluded that there had to be more matter within those galaxies that was not visible to account for the motions of the stars. So this, I guess, is another check in the column for the existence of dark matter, but there is more work to be done. Also in the news, could aliens be communicating with neutrino beams? So most of you are probably familiar with SETI, the search for extraterrestrial intelligence. They scan the skies for signals in the radio waves band and have recently developed technology to also look for laser communications. There is another group called METI, Messaging Extraterrestrial Intelligence, and they are mostly focused on sending signals out into space to communicate with potential extraterrestrial intelligence. But they also have some ideas on how we might be listening. From Dr. Morris Jones, we are not really sure of how extraterrestrials would communicate with us. Would they use radio waves, lasers, or something more exotic? Perhaps the universe is awash in extraterrestrial signals that we cannot even receive. SETI and METI practitioners spend a lot of time wondering how a message would be encoded in terms of language and content. It's also important to consider the medium of transmission. So he is suggesting here that there are other ways, such as neutrino beams, that could be used for communication. Now, neutrinos are very difficult to detect. Some of our detector facilities include the Super Kamiokande facility in Japan, Ice Cube Neutrino Observatory located at the South Pole and operated by the University of Wisconsin-Madison, and the Sudbury Neutrino Observatory located in a former mine near Sudbury, Ontario. These are the, if you've ever seen them on TV, the big, huge rooms way, way underground, full of water, usually. So I guess it's possible, that's something we have to consider. That there may be communication out there that we don't yet understand how to intercept and to read. At this point, there is certainly no reason not to consider all possibilities. Astronomers observing a massive dying star got a bit of a surprise recently. They were expecting a supernova, and instead it just kind of went, and nothing happened. So they are considering the possibility that they have observed the formation of a black hole. Instead of exploding and creating more material to generate maybe new smaller stars and solar systems, it probably just collapsed into itself and formed a black hole. This star, 25 times as massive as our own sun, should have exploded in a very bright supernova. Instead, it just fizzled out. This happens somewhat often. As many as 30% of such stars under observation may just collapse into black holes with no supernova. Researcher Christopher Kochanek, a professor of astronomy at Ohio State University, said that if a star can fall short of a supernova and still make a black hole, that would help to explain why we don't see supernova from the most massive stars. So interesting new observation there, and just rolling right along with the space observation information this week. LIGO has detected gravitational waves for a third time. LIGO is the Laser Interferometry Gravitational Wave Observatory, which recently, just last year, detected gravitational waves, which finally gives physical evidence to something that Einstein hypothesized a very long time ago. And in this case, it has made its third detection of black holes merging and sending out gravitational waves. These two black holes, one estimated to be 31 times larger and the other 19 times larger than our sun. Massive, I should say, not strictly larger, but more massive. The signal captured by LIGO lasted less than 0.2 of a second, and in just that tiny fraction, they were able to calculate that the black holes whirled around each other 6 times before merging into a giant 49 solar mass black hole. This gave off an enormous amount of energy, but still very briefly, in the form of these gravitational waves. And in the long run, the great thing about LIGO is it opens a new window into the universe. This is a whole new method of collecting data from out there, and that's really what it's all about. First we have visual light. We have the visible light spectrum, either with just our eyes or with telescopes, and then we get to radio waves, microwaves, gamma rays, X-rays, all those different ways we can peek into what the universe is made of and add gravitational waves to that list. There's some new possible breakthroughs in the realm of plasma propulsion, often used currently in ion engines. A plasma propulsion system relies on electric power to ionize propellant gas and transform it into plasma, negatively charged electrons and positively charged ions. These ions and electrons are then accelerated by the engine nozzles to generate thrust and propel a spacecraft. This is something that has been used, for example, on NASA's Dawn mission, currently exploring Ceres. The first ion engine thruster was tested in the 1960s and 70s. Plasma propulsion is not very fast now, but it is considerably more fuel efficient than chemical rockets. So spacecraft and satellites, particularly ones already in space, can benefit greatly from this kind of technology. However, they need something known as a neutralizer, which allows the spacecraft to remain charge neutral, is an additional drain to the power of the spacecraft. However, a team of researchers at the University of York and École Polytechnique are investigating a plasma thruster design that would do away with that neutralizer altogether. They have put out a paper in the Physics of Plasmas, led by Dr. James Dendrick, and have designed something that would be a self-regulating plasma thruster. So, futuristic high-tech methods of propulsion are out there now, and they're getting better. So I would expect this to be tested, and we'll see if it works, and I am sure it will be put to use. A quote here from their study: "Its design is based on the principle of plasma acceleration, whereby the coincident extraction of ions and electrons is achieved by applying an oscillating electric field to the gridded acceleration optics. In traditional gridded ion thrusters, ions are accelerated using a designated voltage source to apply a direct current electric field between the extraction grids. In this work, a DC self-biased voltage is formed when radio frequency power is coupled to the extraction grids due to the difference in the area of the powered and grounded surfaces in contact with the plasma." I won't pretend to understand that at all, but I know that ion thrusters are cool, and making them better is also cool. NASA has moved up the launch date for its Psyche mission 1 year to 2022, with a planned arrival in the asteroid belt in 2026, 4 years earlier than the original timeline. So that is very cool. The Psyche mission is really cool. And the mission itself is named after the asteroid that it is going to look at. The asteroid Psyche has a diameter of 120 miles, 200 kilometers. It's one of the 10 most massive asteroids in the asteroid belt. Like certain meteorites found on Earth, it's made almost entirely of nickel-iron metal. This metal is usually found in just tiny flecks in stony meteorites, but this whole thing is nickel iron, and that is really cool, and that's one of the main reasons we're going to go look at it. One of the hypotheses for how we ended up with such a large piece of nickel iron metal is that this is the core of a developing planet, a protoplanet, probably once covered by a mantle of rock. As these things clump together to make larger and larger planetoids, protoplanets, they heat up, and the heat causes the metals to melt and sink toward the core. But then at some time in the distant past, this protoplanet broke apart. Probably there are some asteroids or something out there that used to be attached to this thing, but now it's just floating out there without anything else on it. It gives us a potential opportunity to get an up-close observation of the kinds of material that might be at the core of our own planet. So that is very fascinating. There's also been a few brief stories, I think I covered some not too long ago, about asteroid mining and its potential impact on our economy, and the fact that it probably will start to grow pretty soon. I don't have a specific mining story this week, but I did also find the Psyche asteroid is estimated to be worth 10,000 quadrillion dollars. That's a lot of zeros, and people think generally the stories I found reporting the value of the asteroid said that bringing it back would completely wipe out the economy. However, that's not really going to be a problem. As large as this is, I doubt bringing it back to Earth, or even bringing that much material from it back to Earth, is ever going to happen. However, mining Psyche in the asteroid belt and building something out there with it is certainly a possibility, and will keep Psyche in the news for quite some time, I think. Also in space news this week, I've been sitting on this one actually for a little while. A company called Made in Space, a California-based company, which owns and operates the commercial 3D printer aboard the International Space Station, is developing new technology they are calling Archinaut. This technology will be designed to assemble large structures in space. Of this, as Made in Space CEO Andrew Rush said, the real difference maker for this technology is in the area of being able to put stuff up that you can't origami fold for launch, or that would be really, really difficult to do with a traditional deployable system. Building structures off Earth would also allow them to be space optimized, he said, rather than engineered to survive launch. The Archinaut concept integrates a 3D printer and flexible robotic arms into a single spacecraft capable of manufacturing parts and putting them together in space. Now, I've talked about 3D printing in the past. I've talked about the potential of 3D printing in space rather than manufacturing here and sending it up there. This is just a great example of, I can say it's happening now. Well, they're developing this technology now. It will be deployed soon. And one thing that I haven't mentioned, I think, about some of the technologies that I talk about here that are being developed and deployed now, you can go work for these people. I've talked about in my jobs show before. What are there going to be any jobs in the future? What will they be? Private space enterprises with things like 3D printing, asteroid mining, they're working now. So if you're in the tech field, or if you're looking to go to college for something and wondering what to study, want to do something sciencey, look into robotics and 3D printing and space engineering. These places, I'm looking at the Made in Space website right now at their career page. They're looking for, they don't have anything entry level at the time, but they are looking for, among other things, a payload safety engineer and a technical illustrator. So this is just, it would be cool. I mean, like if I were like 16 right now and thinking about what I was going to do, there would be so much I would love to do. I probably could have in those many years ago when I decided to be a musician instead. But when I went to college, stuff was interesting, but it was all internet. The internet was kind of new, and it was all about computers. The field of robotics and space engineering and 3D printing was not what it is right now, and it's just fascinating. So if you need a job, if you're looking for a future career, look to space. And speaking of space, I could not let this week go without again mentioning Juno. The Juno mission at Jupiter continues to send back incredible images. There's not much to say about them other than to say go look at them. I will have links in the show. They are just stunning. It almost looks unreal that it's we've never seen anything like this. I suppose if you're a younger person listening to the show, maybe this is totally normal for you. It's kind of hurts my brain a little bit to think that there are people for whom, this is always the way we will know Jupiter. For most of my life, Jupiter has been kind of a fuzzy, vaguely striped thing with some swirly clouds and a big red eye on it. This is as close to being there as certainly as I will ever get, maybe as anyone will ever get, because it's probably pretty dangerous to be that close to Jupiter. Go look at the pictures. It will make your day for sure. And that's the show. That's a lot of news. I actually didn't expect the show to be that long this week, but it is. It's one of my longer shows. Lots of space news, and there's probably something fascinating that I missed. So be sure to go to Earth and Sky, Universe Today, space.com, those websites. They will keep you up to date on all the latest space news. And also go to panfuture.org for all the show notes and all the links to the stories I covered and all the cool stuff and all those awesome pictures of Jupiter. Also from panfuture.org, you can email me, find me on Twitter, Facebook, all that good stuff. And, I could have started the show with a rant, but I kind of left it for the end. So if you want to skip it, that's totally okay. Let me just say, let me leave you with this thought this week. If you're going to skip my little rant, which is totally cool, let me leave you with this positive note from friend of the show and author A.C. Hashem. I have studied the past. My eyes have grown tired of the present, and so I dream of the future. That's a lovely thought. Pause for a few moments. Now the rant. One reason I do this show is to be positive. I'm not a naturally happy person, and I wanted to bring something into my life which was good news first. But boy, sometimes you can't keep out the bad news. And I will try my best to keep this podcast as a clean podcast and not have to put a parental advisory sticker on it. But Donald Trump is a moron. The utter denial of everything scientific. It's not just climate change. That's obviously the thing this week that has set me off. It is suicidal to take this kind of an attitude. We are altering the planet in ways that we have never been able to in most of the history of our species, and it will have consequences that will reshape the face of the planet forever. And at this point, unless we pour Defense Department type money into the technologies that can draw carbon out of the air and geoengineer things, we're going to have to deal with very serious consequences. And if it's not climate change, it's something else. It's deep sixing the education department. It's Donald Trump has put in place people, Scott Pruitt, Betsy DeVos, people who are there to dismantle the agencies they're in charge of. We need these agencies. I know some of you don't like the federal government, but the federal government sometimes is the only entity that can move on certain issues. Pollution does not stop at state lines. The EPA, despite all its flaws, clean water and clean air is a good thing. Education for everybody is a good thing. And doing things because they're good for people, not just because they make you a bunch of money, is a fine reason to do things. If you make money in the process, that's fine too. But if you're only doing things to make money and you're basically screwing over everyone else, then you're an idiot, you're a threat to civilization, and Donald Trump is at the top of that list. And I guess, judging by the reaction this week, I think the rest of the world understands. And I will say, I know I have at least a few international listeners. It's been nice knowing you. Good luck. Carry on without us. Hopefully we'll get this train back on the tracks soon. And before I actually have an aneurysm, I'm going to end my rant there. Wrap it back around. Take a breath. Have some more coffee, because there's never enough coffee. And I will say thank you for sticking with me through this rant if you have. And please feel free to drop me a line. If you disagree with me, let me know. I am always up for a level-headed, rational discussion with people who disagree with me. If you just want to yell at me or throw around, false information, forget it. But after all that, still, and as always, I will talk to you again in the future.
to fight. Imperative, so they say. But to die, no need for me, I pray. I'm not scared of all the pain out there. On this world we share. Wake me when the worst is finally over. Tell me when it's safe to love. Show me where I can find my courage. Tell me when the storm is past. Work through feelings that I've long repressed. But do I have the will to pass the test? Wake me when the worst is finally over. Tell me when it's safe to love. Show me where I can find my courage. Tell me when the storm is past. I can't let you break my spirit today. Oh, stand by as you rip all freedom away. To fight, imperative, so they say. But to die, no need for me, I pray. Wake me when the worst is finally over.